total of number of courses when you have to take level from 0 to this. Okay, this is the number of courses. You're given the prerequisites array where this is AI B indicates you have to take the course BI first if you want to take course AI. Okay, so B2A is an edge, indicates that the course you return true if it's possible to finish all the courses, otherwise return 0, return false, otherwise is it a cycle detection in a directed graph? Cycle detection in a directed graph. Yes, I think. Okay. Is there a cycle in the directed graph? I think yeah, we can solve it using DFS. Okay, so DFS at the node U, and what's the pair? Let's see. So at node U, its mark is in the stack. The stack is equal to true, so we'll need the stack also. Vector of boolean stack mark it as true, then go to all the edges. So for V over adjacency of U, we need to create the adjacency. Pass it here. Vector so we have the adjacency of number of courses, and then for each prerequisite so let's see what there is an edge adjacency of prerequisite of vector. So must take course BI first if you want to take course AI. That means B to A is an edge. So from B to A. So from B to A, the prerequisite of I. So from 1 to 0, from index 1 to index 0, there is an edge. From B to A is an edge. That means if you want to take A, then you have to complete B first if you want to take A. Okay, fine. Then is it possible to complete all the courses? So we have to find if there is any cycle in this directed graph, then it is not possible. So let's run a DFS from the node 1, pass the is it inside the boolean of stack number of courses, and everything is false. It means nothing is inside the stack. Run a DFS from 1. we'll have the visited also. So put it inside the stack, remove it from the stack. So once the DFS from here is done, remove it from the stack. So every edge, so if all the prerequisites are unique. Means there is no parallel edge. But what if from 0 to 1, 1 to 0, there is an edge? What will happen? We push 0, 1, from 1, we again come to u. Okay, so if v, from u to v, I'm going to write from u to v, if v is inside the stack, that means, so if v is inside the stack, that means return false, cannot be completed otherwise. That means v is not inside the stack and v is not visited. Stack, then return false. And if it is not visited, if it is not visited, then run a DFS from v, pass the current stack, pass the adjacency list. Have to have the vector of bool visited also. DFS v stack visited adjacency. Stack of u is true, go to v, v return false, stack of v, equal to true, stack of v false if it is not visited, if visited is false, and run a DFS. Okay, so everything is false. I think let's mark a visited also. Visited also. Visited. Let's mark a visited also with the now go to for all the nodes courses I++. So if it is not visited, so if it is not visited, that means we can fire a DFS from I with the stack. What's inside the stack? So okay, I think this will be fine because everything becomes false after a recursive call. And then we have to pass visited and adjacency list also. So if the answer is false at any point, we can return false. If answer is false, that here what it runs, that means there is a cycle. If there is a cycle, then return true. It is there a cycle? Find. Is there a cycle? So from u go to all the nodes. If u goes to any node in the current stack, so if stack of v is true, that means there is a cycle, so we can return true. Otherwise we can return false and return the value of this otherwise find me the value of next this recursive call and return the so after this, that means there is no cycle. So if there is a cycle, return false. There is no cycle, that means return true. It should work. Okay. What the? So 1 to 4 is an edge. Why it is not working? So did I miss anything? 1 to 4, 2 to 4, 3 to 1, 2 to 4, 3 to 1, 3 to 2. 3 to 2. It's an edge. Three to 2 is an edge, and 2 to 4 is an edge. To 4 is an edge. Is it possible? So from 3 to 1 to 4. So from 3 to 1 to 4, 3 to 2 to 4. So if I complete 3 first, then 1, then 2, then this value 3, then 1, then 2, and I can complete 4. So answer should be true. Output is false. Why? Output is false. Why? Did I miss anything? Labeled from 0 to 1. Mistake. So if you can finish all the courses, otherwise return false. So I have to find cycle. So from this you can finish number of courses, prerequisites, number of courses. So go to all the prerequisite and create a graph. So A to B, we are given 1 to 4 A to B. That means you must take course BI first if you want to take course. For example, if the pair 01 indicates that you have to take course 0, it's that to take course 0 you have to first take course 1. So that means from 1 to 0 is an edge, right? So from 1, so if I go to from 1 to 0 is an edge. So in the adjacency list of 1, 0 will appear. That's what. So I think I framed it wrong here in the reverse direction. So from 1 to 4, not from 1 to 4, from 4 to 1 there is an edge. 4 to 1 is an edge. 4 to 2 is an edge. Okay. So 4 to 2 is an edge. So from 4 to 1, 4 to 2. Then from 1 to 3 is an edge. So from 1 to 3 is an edge. From 2 to 3 is an edge. From 2 to 3 is an edge. From 2 to 3 is an edge. So same. So 4, then 2, then 1, then 3. So what it is doing? So stack adjacency of number of courses. Go to everything and put prerequisite of 0 and stack and visited number of courses, everything is false, and go to 0 to number of courses. If it is not visited, start a DFS. If there is a cycle, return false, otherwise return true. So my answer is false. If there is a cycle, it is forming a cycle in this. Okay, so answer should be true, right? Answer should be false, right? From 0 is not visited, visit 0, so DFS at 0. Answer should be true, but I'm telling false. Why? If I run a DFS from 0, it will mark 0 as true, and there is no H0, mark 0 as false and return false. So if it is written false, that means there is no cycle. Fine. Go to 1. Go to 1. So 1, from 1 it will try to do DFS of 1 to 3. From 1 it will go to 3. There is no cycle. Fine. From 4 it will go to 1 to 3. Now from 2 it will go to 3. So 3 is already visited, so it will not go here. If it is inside the stack, it's not inside the stack, and if it is not visited, it will false. It will start from 3. I think from 4 it will not go anywhere. So I think it is false, then it is true. Why my answer is false? Number of courses is 5, and this is trace and test cases. Expected is true, output is false. Yeah, expected is true, fine, but why it is outputting false? Everything is false, everything is false. It is not visited. Am I marking it as visited somewhere? Oh, it should be marked as visited now. So visit it and then do whatever I want. Okay, again same problem. Mark it as visited and go to, so if it is not visited then only do a DFS. Do a stack visited adjacency. String of view is false and return false. prerequisites. Stack visited. Whether I have a cycle or not. If it is inside the stack, there is a cycle. Okay. If it is not inside the stack, then what happens? Let me check. Should I go to V again or not? If it's not visited, then go here. Yeah, it will throw compilation. What could be the from 4? Okay, let's see. From 0 it will go visited of 0 is false, so it will try to do DFS from 0. The stack is same, visited is the same, adjacency list. Okay, so 0 stack is 0, true, which 0 is visited, go nowhere. The adjacency of 0 is what, empty. Adjacency of 0 is empty, so it will not go here. Return false. It is false, then go to 1. From 1 I will do a DFS 1 to 3. From 1 go to, so 1, so for V adjacency of U for 1 is inside the stack, mark 1 is visited and go to adjacent, so it is 3 is not inside the stack and 3 is not visited. Go and check if there is a cycle from 3 with 1 in the stack, so it will go, and 3 is marked as in the stack and 3 is marked as visited. There is nothing here, so 3 will return false. Okay, so 3 will return false. Okay, so before returning false, return the value of, so 3 returns false. We are returning here only, we are not completing this operation. So let's have the value bool answer its cycle. Its cycle is false, and return its cycle. Its cycle is equal to this. Its cycle is equal to true. Now it will work correctly. Yeah. Okay, great. What the fuck now? Okay, 0 to 1 to 2 0. What's this? So from 2 to 0 we have an edge. From 2 to 1 we have an edge. Let's write in here only. So 2 to 1 is an edge, and 0 to 2 is also an edge. Yeah. So 0 to 2, 2 to 0, it will come again here. I covered that case, right? So from 0 in the stack and its cycle is false, and then go to 2 is, so if we stack of 2, if 2 is in the stack, no, and 2 is not marked, so go from 2. So from 2 it will go to from 2 it will go to so from 2 it will go to 0. Okay, so 0 is in the stack, yes. From 2 it will go to 1. 1 is in the stack. 2 it can go to 0 also. It will go to 0. So if I've already got this answer as false, then why to override this now, right? So from 0 it will override, 1 will override. So I think this recursive case is false, is wrong. So better to write in this way. So if I do, if it is not visited, okay, that was fine. So if it is inside the stack, then return true. That means we don't, there is a cycle. If it is not visited, go here and go in the cycle, and if there is a cycle, if it is not visited and DFS of this is correct, then return true. Yeah, why to waste that value? Return is cycle. Return false here. If it is not visited, as well as this gives me a true answer, then that means we have to return true. If it is inside the stack, then directly return true. Otherwise it will get me false answer. What now? Okay, compilation error. Okay, fine, great. It was. So why I'm not able to do the recursion? What was the problem? Recursion king, man. Need to focus. So stack visited, so go here, and so if it is saying that there is a cycle, then directly return false. So I need my DFS function returns is there a cycle or not. Okay, market visited, put it in the stack, go to all the neighbors. If there is a node, there is a neighbor which is inside the current stack, then that means I have got the cycle. No need to do anything directly, because answer is false. Directly we can return, as well as. So if my otherwise, second case, if that node is not visited, as well as from that node there is a cycle, then also I can return true. What if I don't return true directly? So if in the previous one, so if I don't return true, if it is not visited, I go and find is there a cycle. It will keep on overriding, right? So even if I get a cycle from the first V node, first neighbor, the second neighbor, second neighbor, if there is no cycle, then first neighbor's cycle, so first neighbor's cycle whatever I got is wasted. That means if there is a cycle, I need to directly return it. So if I directly return it, yeah, it will override otherwise. Yeah. Otherwise I can apply also and here, and let's try. So this should be and. So this, if there is a cycle, so it is false. If there is a cycle, or if any of the neighbor gives me a cycle, so it should be or. If any of the neighbor gives me a cycle, then I'm good. This will become true, and then yeah, it should also work. Yep. And what was the error in this one? So I'm directly returning it. So this is wrong. Why? Because that current u will not be popped from the stack. So this line will never execute for u. So if u has at least one neighbor which is not visited, then this function is directly. So return should not be written 2 times. If I want to return something here, yeah, this point, right, because it will return directly from here. This will never be popped out of the stack, the current u. Yeah, this was the problem, I think. Yeah, great question.